This lecture continues our coverage on open economy macroeconomics by developing the building blocks of an open economy model of output determination in the short run. How is this lecture linked to our prior coverage? Well, first, if you recall, in our unified model of exchange rate determination, we assumed that output in the short run was exogenous. We now provide a macroeconomic model for explaining how output is determined in the short run. It's a very familiar model, which we only now extend to make applicable within the context of an open economy. To keep the model tractable, we assume the following holds true for countries that are open. Prices are fixed. This pins down expected inflation to zero. Domestic levels of government spending and taxes are also assumed fixed at some level. Foreign output and interest rates are fixed. This allows us to focus analysis on some domestic economy. The net unilateral transfers and net factor incomes from abroad are assumed to be negligible and so equal to zero. This allows us to focus attention on the trade balance alone, which for all practical intents and purposes is the dominant component of the current account. Assuming further that consumer sovereignty holds, goods are produced in an economy because there is demand for them. That demand is represented by the total planned spending or expenditures in the economy. This is what the circular flow diagram indicates. Planned spending in an open economy adds the gross national expenditures, which comprise of C, I, and G, to the trade balance, which is the net planned spending from abroad on US output. The sum of this gives us GDP, the gross domestic product. So the total output of the economy, which is the GDP, is equal to the sum of consumption spending C, spending by businesses I, and government spending at all levels of the economy G, as well as the net spending by the foreign sector, that is the trade balance TB. Now let us take a look at how each of these component parts of planned aggregate spending is in turn determined. Consumption spending, which is the total planned spending by individuals and households on goods and services, is assumed to depend on income after taxes, as well as an exogenous component. In notational form, C is a function of YD and C bar. YD is technically called disposable income and is equal to national income Y minus the total level of taxes T. C bar captures all exogenous influences on the level of consumption, such as any existing wealth saved up or inherited. Investment spending is the total planned spending by businesses on fixed investments and inventories. It is assumed to be dependent on the real interest rate and an exogenous component. So in notational form, I is a function of lowercase I, which is the nominal interest rate, since by assumption it is equal to the real interest rate, and also a function of I bar, which captures some other exogenous effects, such as the profitability of capital. Government spending is the total spending by the government at all levels on consumption and investment goods and services. The level of government spending is assumed to be exogenously determined, so that in notational form, G is equal to G bar. As we have government, we also have taxes, which are assumed to be lump sum and exogenous for ease of analysis. So T is equal to T bar. Now, government spending need not be limited to the total amount of tax revenues raised, as G could exceed T, in which case the government is running a budget deficit. The trade balance is the difference between an economy's exports and its imports. So it measures the net spending by the foreign sector on goods and services produced in the domestic economy. The trade balance is assumed to be dependent on the real exchange rate, disposable incomes at home, and foreign disposable incomes, as well as an exogenous component. So in notational form, the trade balance TB is a function of EP star bar divided by P bar, which is the real exchange rate, where E is the nominal exchange rate, YD, or Y minus T, and YD star, that is Y star minus T star, where the asterisk represents the foreign country's variables, and TB bar, an exogenous component that could include changes in preferences across globally produced products. Let us take a closer look at the non-exogenous determinants of the trade balance. First, the real exchange rate. The reason for our focus on the real exchange rate is because we are trying to determine output in the short run when PPP does not hold, and where as a result the real exchange rate is not equal to 1. If we consider some two countries, say the US and Japan, with the US being the home or domestic country, then the US real exchange rate is given by the dollar-yen exchange rate multiplied by the Japanese price level and divided by the US price level. In the short run, these price levels are assumed to be fixed. If the nominal exchange rate, that is the dollar-yen exchange rate, depreciates, which is it rises, there will also be a real depreciation as the foreign or Japanese basket becomes more expensive. This will lead to less imports of Japanese goods into the US and also to more exports of US goods to Japan. So the US trade balance would increase. If on the other hand the dollar-yen exchange rate appreciates, that is, it falls, then there will be a real appreciation as the US basket now becomes more expensive. The result is less US goods will be imported by Japan and more Japanese goods will be exported to the US. So the US trade balance would decrease. This phenomenon is known as expenditure switching. How does the home country's disposable income influence the trade balance? Clearly, the higher are the incomes after taxes, the greater will be spending levels on all goods and services, not just domestically but also abroad. So higher disposable incomes reduce the trade balance as imports increase, and similarly, lower disposable incomes increase the trade balance as imports fall. By analogous reasoning, foreign disposable incomes also influence the trade balance by increasing it if they increase and decreasing the trade balance if they are reduced. Now we are ready to put together the familiar income expenditure model. The total income in the economy, Y, is equal to GDP by the accounting identity in the NEPA and the assumptions that the net unilateral transfer and net factor incomes from abroad are zero. Therefore, macroeconomic equilibrium will have that Y is equal to GDP. And GDP is given by the total planned spending in the economy, or what we will now call technically aggregate demand, AD, and which comprises consumption, investment, government, and the trade balance. Therefore, Y is equal to C plus I plus G plus TB. We can expand on this model to show that in equilibrium, national income or total output Y is determined by the things which drive the spending components of aggregate demand as stated on this slide. From this setup, it's immediately seen that the output in this economy is determined by how incomes in this economy affect planned spending, along with some other non-income determinants that are going to be assumed going forward as exogenous in this model. Before we look at a diagrammatic form of the model, it's worth noting the important concept of the marginal propensity to consume, or the MPC. The MPC tells us how much spending will be carried out by households for every dollar of income earned. In an open economy, the MPC is made up of two parts: the marginal propensity to consume on home products, MPCH, and the marginal propensity to consume from spending on imports, the MPCF. As we shall see, these MPC concepts help to drive the outcomes observed in the model. Depicted in diagrammatic form here is the income expenditure model in equilibrium. In diagram form, it's also called the Keynesian cross, given that it appears as a cross in the aggregate demand income output plane. The Keynesian cross is made up of the 45-degree line, where every point on that line reflects combinations of output and aggregate demand that are equal, and the aggregate demand function that captures the actual levels of planned spending in the economy. The slope of the aggregate demand line is given by the MPCH. The equilibrium in this form occurs at the intersection of the AD line and the 45-degree line. At that point, actual levels of planned spending and output are equal. Suppose, however, that output was at Y1. Then, as seen, output is greater than the planned level of spending, which is AD1 at that output level. This means there is too much production taking place, as inventories are building up faster than desired, so production will be cut back and output will fall. This will continue until the economy is back to Y star, where planned spending is now equal to AD star, which is equal to total output Y star, and the economy is in equilibrium. Similarly, if output was at Y2, which is a level where planned spending is now at AD2 and is greater than the output level, now there is insufficient production to meet the level of demand in the economy. Businesses will therefore ramp up production and output will increase until it gets to Y star. At that level, planned spending is at AD star and equal to total output at Y star. The economy is therefore back to equilibrium. From this equilibrium setup, it's now clear how output changes in the short run. Output in the home country will change when any of the non-home income determinants of the components of aggregate demand change. Precisely, it will increase if there is a positive effect on the home's autonomous consumption, autonomous investment, or autonomous trade balance, and if government spending increases or its taxes are reduced, or if its interest rates fall or its prices fall. Output will also increase if the foreign trade partners' disposable incomes increase, foreign prices increase, or the nominal exchange rate in direct terms depreciates. We can see why as depicted here. Any of the above mentioned changes in the direction stated will cause the aggregate demand function to shift up, reflecting an increase in the level of planned spending that results. There will now be a disequilibrium at the initial equilibrium output level, as planned spending is now higher than output. and output will increase until it gets to Y double star, where planned spending is now at AD double star and equal to total output at the new level of Y double star. The economy is now back in equilibrium at a new higher output level. In the same vein, we would expect homes output to fall when there is a negative effect on homes' autonomous consumption, autonomous investment, or autonomous trade balance, and if home taxes are increased or if its interest rates or prices go up. We will also expect homes output to fall if the foreign trade partners' prices fall, or their disposable incomes fall, or the nominal exchange rate in direct terms appreciates. Again, we can see why this happens in diagrammatic form. As any of these changes and in the direction stated occurs, the aggregate demand function will shift down to reflect the resulting decrease in planned spending. Now, at the initial level of output, aggregate demand is now lower, prompting a cutback in production to set in as unwanted inventories build up. So output falls until it gets to Y double star, at which point planned spending is now at AD double star and equal to the total level of output at Y double star. So the economy is back to equilibrium at a new lower level of output. Let us now turn to an algebraic analysis of the model. Suppose that the component parts of aggregate demand were given by the following functions as stated on this slide. If further, the level of taxes in the home country was fixed at $4 trillion and the level of foreign disposable income at $2 trillion after conversion at the current exchange rate, if the nominal interest rate in the home country is 5% and the home real exchange rate is 1.25, we are asked to compute the equilibrium level of output in this economy, along with the trade balance. So how do we proceed? First, we set up the income expenditure model. We have that output is equal to planned spending, which in turn is given by its component parts. We plug in the functions that correspond to each of consumption, investment, government, and the trade balance. We then plug in the magnitudes provided for all other variables, and solving this we obtain that output Y is equal to $13.6 trillion. We now take the function for the trade balance and plug in the magnitudes provided, including the value of output for income in the model, and find that the trade balance is $1.05 trillion negative, which is a deficit. We can now ask further questions such as, what would happen to output in this economy if interest rates increase to 8%? Or what would happen to output if instead the foreign country's disposable income increased to $3 trillion? Or what would happen to output in this country if there is a real appreciation that occurs so that the real exchange rate is now 1.15? In the first situation where the interest rate is increased to 8%, we simply substitute 0.08 where we have the interest rate in the setup from before instead of 0.05. We then walk through the analysis as before and obtain that the equilibrium output is now $13.225 trillion. Intuitively, the higher interest rate by reducing investment spending reduces planned spending so that in equilibrium output also falls. In the second situation, we again effect this change in foreign disposable incomes in the trade balance function and compute the new level of output, and this is now $13.725 trillion. Again, intuitively, because foreign disposable incomes increased as they experienced growth in their output, this also meant more spending on homes goods in the form of imports to their country from home. So higher home exports to foreign increase the trade balance and planned spending, so that output also increases at home. In the third situation, the real appreciation experienced in the home real exchange rate is again affected in the trade balance function by plugging in the new real exchange rate in the formula. The equilibrium level of output is now computed to be $13.55 trillion. This is a reduction in output, and this is expected since the real appreciation has made home's basket more expensive than that of its trade partners, and therefore results in fewer exports from home and more imports from foreign. The trade balance therefore falls, as does planned spending. Output falls therefore to restore equilibrium in the model. Now that we have seen how the income expenditure model, or the Keynesian cross, works, our next task is to extend this analysis to a general equilibrium setting in order to explain fully how output is determined. That is the next lecture, where we develop the ISLM-FX model. But first, take the quiz associated with this lecture to both reinforce the concepts and ensure that you understand how the model works.